All right, hey guys, we are moving into the second half of Unit 8, and we are moving away from angles and arc measures, and we're going to be finding lengths of segments involved in circles. So we are going to run through three theorems. And you can add these to your brown sheet or just add them to your notes. There's three theorems here, and then we are going to look at three examples. So pretty quick notes here. Pause as you need to. But the first one is the chord product theorem, and it's when you have two chords intersecting in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. And so what that's going to look like for you in this example, if you want to draw it, is that EA times EB is going to equal EC times ED. So the part times the part is equal to the part times the part in those two chords. The second theorem here is the secant theorem. Let's show you what that's going to look like. So you've got two secants going through a circle, and they share the same endpoint outside the circle. Then easiest way to say this is that it's the outside part times the whole secant is equal to the outside part times the whole. So in this case, it's going to be EA, that's the outside part, times the whole length of that secant, which is EB, is equal to EC, which is the outside part, times the whole thing, ED. That's the secant theorem when they meet outside and share an endpoint outside the circle. The third theorem is the secant tangent theorem. And what it's going to look like is this, where we have one secant. Sorry for that canine interruption there. So here it's going to be the tangent part times itself is equal to the outside part times the whole of the secant. So it's going to be EA, the tangent is going to be squared, and that's going to equal the outside part EC times the whole thing ED. All right, an example of the first secant we looked at, find the value of x. These are the chords that are intersecting inside the circle. So you are going to find the product of the parts. So in this case, 3 times 6 is going to equal 9 times x, which gives us 18 is equal to 9x, and x equals 2. Example 2. Find the value of x. So here's where we have two secants that intersect at point L outside the circle. So it's going to be the outside part 9 times the whole thing, which is going to be 9 plus 11 is 20. And the other secant, the outside part is 10 times the whole thing, which is 10 plus x. And then you just work down and solve that equation. So 180 is equal to 100 plus 10x. And as you continue on to solve that, you're going to get x is equal to 8. Continuing on, example 3. This is where we have the tangent of 24. The tangent part is 24. And the secant is 12 plus x. So this is going to be 24 squared. The tangent squared is equal to the outside part times the whole thing. So we're going to get 576 is equal to 144 plus 12x. Solve that for x, and x equals 36. So that's it for the lesson on 8.5. Go back and rewatch and copy down whatever you need to there.